So I think we've got to time just to try to keep ourselves on track so the people who are ducking in and out of different talks know what they get to. So this talk that Valentina has lined up, I think, is tackling quite an important issue, which is we talk a lot about continuous delivery. In fact, if you were at the Perfect is the Enemy of Good talk that Emily and Mihaela did earlier this morning, you know, people talk about the virtues and the benefits of making many frequent changes to production, right? And how that's great. But a lot of people, when they hear this the first time, it makes them quite nervous because they think, oh, it's all very well for Facebook, it's all very well for Google to do these things, but how am I going to get my code base and my situation? How am I going to make changes without you know, stressing myself out, basically, or running risks I shouldn't run? So Valentina has taken a lot of time to kind of carefully run through how you will safely, quickly, easily make lots of changes to your production system and survive continuous delivery in a distributed system. So Valentina, take it away.
Hello, Chris, and everyone else. Thank you for the introduction. Let me see if I can share the screen. Okay. All right, hopefully you can see my presentation. All right, so hello everyone again. Welcome to my talk, Surviving Continuous Deployment in Distributed Systems. Who am I? My name is Valentina Servile. I'm a software developer at ThoughtWorks. I've been for about, I would say, 3.5 years, almost 4. And you can find me at all of these addresses and LinkedIn and Twitter that are down here. You see now a picture of a cat on this slide, but to quote a famous lawyer, I am not a cat. So without further ado, let's get into the content of the presentation itself. So first, a little introduction. What this talk is about. So keeping everything green. I think Chris already did a little bit of introduction to this, but just to repeat, as we know, the latest trend for the industry is to do trunk-based development and continuous deployment, and we like microservices a lot. So everybody is talking about it or working actively towards it or has already implemented it. And certainly in ThoughtWorks, this is something that we consider state-of-the-art in terms of practices. However, there is also a dangerous side to all of these practices, which is this means making quite a lot of rapid changes to our code bases, which will go immediately to production. And as they do so, they will very often in a microservices environment just affect a really complex network of services that are all depending on each other in intricate ways. And so it brings also a lot of risk. Because of this, we can't just do our normal software development every day the way that we used to, maybe before these practices were implemented for us, but there should be maybe an evolution and a special consideration for this kind of risk that trunk-based development and continuous deployment are introducing. So basically, the scope of this talk for me will be to share a workflow that has gone very well for us in ThoughtWorks across several, I would say, large-scale projects that has allowed us to do safely trunk-based development and continuous deployment without having to worry so much every day about these risks. As audience of this talk, we were thinking, okay, let's maybe address teams who are just maybe beginning right now to see their journey with continuous deployment and trunk-based development. So for example, if you are part of a team and this team has just convinced that last very important stakeholder to remove the gate to production, but you're also looking to not break their trust because that took a lot of convincing, a lot of work, and you promise, oh, it's perfectly safe. That is what everyone is doing. However, you're not yet quite super sure of how the day-to-day will look like for you or your team, then maybe this is a talk you might be interested in. And at the same time, something that I've seen quite a lot, especially in ThoughtWorks, sometimes people might have been developing for a while. However, they might not have seen yet a team that has a full workflow where they commit and their commit goes to production immediately on trunk. Sometimes people might not be sure once they join such a team for the first time how this will affect the workflow of development that they have developed so far. And they're not sure, might my commits break something now because this is enabled, because there's no person actually controlling what goes to production and when. So how do I change things? So this is also a talk for you if you're in that situation. Hopefully you might find something useful in here. I would like to also have a couple of quick disclaimers. So the first one is these practices are not enough for continuous deployment. So please don't look at this presentation and if you had never considered continuous deployment before, then immediately remove the last gate to production, because I would like to encourage you to please have a strong technical foundation first and make sure that your team is mature enough in order to take this step, because it's quite an important one. So for example, you might consider, what is your relationship with your stakeholders? Do they trust you? How strong is your TDD culture? Do you have a zero downtime deployment strategy? That's quite important. Do you have a comprehensive suite of tests, a pipeline that you really, really trust? And these are some of the prerequisites that I would recommend that you think about before you actually start doing it. Another disclaimer is this guide is very opinionated, because it's based on, well, the author, so myself, my past project experience, and I happen, of course, to be a human being, and as a human being, I have a lot of bias and opinions, especially when it concerns software development and how it should be done. And they have resulted more or less in the approach in this guide. However, please, I would like to remark this talk is not meant to evangelize an approach, but is more of a showcase of a workflow which it has reliably worked for us in production and across several large-scale software projects. So now, with that out of the way, we can start with defining a little bit more what we understand by a distributed system, which is part of the title of the talk. So instead of giving a boring definition, I thought I would maybe present with you an example. So here you have an animal shelter management system with a very modern UI, as you can see. So this is simply a very, very simple system where a volunteer of an animal shelter can open in this UI and more or less have an idea of which animals are there, what are they up to, what are their details, and maybe keep track of several things concerning them. Now, architecturally, I tried to simplify and understand what is maybe the simplest, most idealized version of a distributed system that everybody might be familiar with. So maybe this system might have an API. So a backend which talks to some kind of persistence, maybe relational, maybe not, we don't know. It has, of course, a user interface, and maybe there are some third-party systems that are consuming this API because they need something from us, and maybe we need something from other third-party consumers. So maybe there are some external actors also in a real-world scenario most often. So now that we've seen this example architecture, I'd like to see how it could be split into repositories. We could have, for example, as a common setup, two repositories, one for all of the UI code and one of all of the backend code plus the persistence. Usually they are more or less in the same repo. So now that we've seen this example that we're going to be using throughout the presentation, I would like to talk about what is the mindset shift that we have to acknowledge once we remove that final step to production. So in terms of contracts between the components of this system, before that, what I see people consider most often is the contracts in between our systems and the third parties only. So for example, if our backend is consuming some other team's API, we are consumers and they are producers, and we got a contract in between, maybe some contract testing. Same thing for when we are the producer to some other third-party consumers. However, okay, I would like to propose, we used to think a contract was between our system and the outside world only, but I don't think we think enough about this situation, which is sometimes the distributed subcomponents of our systems also have contracts with each other. So for example, our front end is definitely a consumer of our API in case of a backend, and there is a contract in between. And in the same way, our backend is very often a consumer of the persistence, and there is also a contract in between here. So I think maybe we should consider this more, especially with continuous deployment, and start thinking that every service we develop can have subcomponents which are distributed in addition to other third parties, which are of course distributed. And contracts are actually in play, not only between us and the outside world, but also between different parts of services that we own. So you might ask, how does this really affect the development cycle? For example, in the old way, when we had the gate to production, the order in which the code arrived to production was the order in which it was deployed. So imagine we have our two pipelines for each of the repositories, UI and API, and we would like to develop a change in which the front end is depending on a change on the back end. And we have our development team over here. They can work, for example, on the change of the front end first, release it in the pipeline, and the backend change second, even though the order of dependency is this way. Why can they do this safely? Because there is a gate to production, and so there will be an actor over here which will have to think, okay, what is the dependency actually in these two systems? And might choose to actually deploy them in the order in which the service will not be broken. However, in the continuous deployment way, there is no gate. So the order in which the code arrives to production is the order in which it is developed, because there is nothing stopping it over here from reaching production. So if I have the same situation, of course, my production explodes because I will deploy something in a front end which doesn't have the corresponding feature on the back end, and so we're exposing something broken to the users. What needs to be done is the development team needs to now acknowledge there is nothing stopping my changes from reaching production, so I have to swap the order in which I develop in order to take into account the fact that I don't want to break anything over there. So I cannot just begin implementing my story based on what I think my code should look like. I have to actually give conscious thought on where should I start and why, because I need to plan my releases a little bit differently. I would like to talk a little bit about the nature of changes here that I can push as a developer. So what can affect the contract between components of my distributed system? I chose to categorize them in these two ways. So any change we can make to a code base can be either altering behavior, or it can be changing the code without altering behavior, so refactoring as we know it. And I would like to propose in this talk different approaches depending on the nature of the changes to deal with the fact that now we have to acknowledge the order of development as well. So without further ado, let's look at how we can safely alter behavior acknowledging these contracts. So we will, of course, start again with an example. So we want to add a feature to our animal shelter management system in which, as a volunteer, I would like to see which animals need feeding so that I can keep their diet on a schedule. What does this mean for the UI? It means maybe I will have a button to add a reminder, and maybe something in the menu that allows me to see the list of reminders. So this is the desired feature that our PO maybe just gave us. What is the target state of the system with this feature? So we want, for example, in the UI to have in the menu an item that allows us to go to the reminder section, and an add reminder button, which can be somewhere else in the UI. And you can make a call to my backend where it passes the reminder details. In the backend, we would like maybe to have two new endpoints, one to see the list of reminders and one to create a new one for that user. And in the persistence, of course, we need something to store these reminders. So we would like maybe to have a table with some simple fields like an identifier, the user it belongs to, and at which interval the reminder needs to be. So how can we implement these changes in a continuous deployment environment without breaking production? So if we stick by what we said before, we will need to start with the producers first and then work on the consumers. So in order to have a working feature, we will need to start with the persistence so that then the API can use it and so that then the UI can use the backend. However, is this the only order in which we can work or would like to work? My argument here is maybe not. I would like to talk a bit about the outside-in principle. In ThoughtWorks, one thing that we do very often is we try to develop our features from the outside to inside. So starting from the uppermost layers, going slowly into then maybe a backend or a persistence or anything in the middle. Why is that? Because we would like to validate early our business requirements, and we are designing every layer below according to what the one above needs. So we reduce the risk of writing unnecessary code that is not going to be used by consumers. And also it works very well with the mockist school of TDD, in which again, we design one component at a time, mocking everything below. And as well, it allows us to respect the principles of consumer-driven contracts. However, it means that the order of changes that are ideal for development are, if you notice, exactly the opposite of the order we need to not break the application in production with continuous deployment. So how can we solve this? My proposal here for solving this, which is a technique that we use plenty of times in our teams, is feature toggles, or otherwise you might know them as feature flags, which are a technique to decouple deployment time from the release time. They are flags that allow us to ship alternative code paths within one deployment, and then we can choose between them separate from our deployments. In other words, the code will decide basically between different branches of logic to execute based on the state of this feature toggle. This state should be stored outside of the application so that it can be independent of the deployments. Otherwise, you might otherwise know them in this shape, which is they are most often a simple feature state, if statement. So you can see here, this would be the toggle, and then you have alternative paths under the toggle. So why we want to use them? Because they allow us to decouple the order of changes that we need to not break the contracts in our distributed components by allowing us to hide broken code even if it is in production from users. Other benefits of them is if you want to get fancy and QA in production, some toggle libraries have some very nice features which allow you, for example, to only enable the toggle for one user or one session or one header. As well, if you sometimes you can also configure them per percentage, which allows you to release changes with a slow ramp up. So these are also other additional benefits you might think about when using them. So here, I would say we can go ahead and try to implement our feature with a feature toggle. How would we do it? We would start, as we said, outside in with the UI, which is our outermost layer. And we would add our elements that we want to display in the UI. However, we also want to add a feature toggle, which says if the reminders are not enabled, please hide this from the user so that they don't access broken functionality. Where might we store this state? We don't know. It could be in S3, in SSM, config files, or in the database. There are very, very different options, and it depends on what is most convenient to you ultimately. Then in our implementation, we can move on to the backend. And simply we need to add the endpoints that we want. Of course, this will not work because our persistence isn't implemented yet, so we will get a big ugly exception. However, that doesn't matter, remember, because we have the feature toggle in the interface, so the users will not be able to see it. And finally, we can then move in to our persistence and add any table or any new stuff we need. So this is it. Basically, the summary of this section is whenever you are looking to introduce new functionality in such a system, you can go outside in and use a feature toggle to hide the broken state from the users. Moving on. The second type of thing that we like to do is not add new functionality, but refactor live features. For example, imagine that we are a developer in a team and we happen to read a really nice article on Stack Overflow or on someone's blog that says, oh, by the way, did you think that you should never use floats for money? We're very interested in this article, really understand the motivations, and then we remember. There is a functionality in our magic animal shelter management system that actually looks like it might be affected by this issue. And it is the functionality of the volunteer to add an expense in which they have to enter an amount and then that gets persisted. So we take a little look into the code to confirm our suspicion. And indeed, we see the culprit here, which is we're trying to use floats in the front end when we are getting the amount from the input field, and as well in the backend when we use our entities. So then we look into the repository and we find, oof, luckily, the persistence layer is not affected by this because in the persistence, the amount is stored in cents and not in floats. So still, our API and UI are working with floats, so we need to change it. And we can see here the persistence is still in integer, so that doesn't need to change. So what is our target state? We would like, instead of working with cents only in persistence layer, to actually work with cents all through the application. So basically, immediately when the user inputs the amount, we'd like to parse it as an int and then send it to the backend as cents. And then in the backend, all of our entities, we would like to use integers in cents. However, how can we get the system to such a state without breaking the functionality in production? So, for example, we might decide, okay, let's try outside in again, and let's try changing first the UI to send the integer amount in cents, and the backend to receive floats. But this, of course, will break because the backend will not be ready to receive integers. It will fail to parse the payload. And if we reverse the situation, of course, we are also finding another problem, which is the backend will, even if we change it first, we'll still keep receiving requests with the old payload from the front end, and it cannot read it anymore. So, of course, we are breaking production in both cases. So there is not an order that we can use to develop these changes. So how can we solve this? We can solve it with another pattern that I'd like to show today, which is called expand and contract, or also Martin Fowler, I think, calls it parallel change. This is a technique that we can use to change the shape of a contract in between two components without causing any downtime or degradation. It's 3 phases. So the first phase would be the expand phase. It consists in basically in the producer system, we would like to add the new flow and the old flow to be present in parallel without breaking existing clients. Then in the migration phase, all of the existing clients should migrate to the new flow while the old one is still in place. And then finally, when all of the clients have migrated, we can have a contract phase in which we are finally allowed to remove the old deprecated flow from the interface of the producer. So in order to implement this, we can go producers first, consumer second, because of course, the expansion is on the side of the producer. So we need to do the opposite of what we did before and start with our innermost systems. So like the persistence, the backend, and then the UI. We could maybe use feature toggles as a workaround to this, but they don't have here as many benefits as they might have with introducing new functionality. So I would argue that it's better to use expand and contract than go inside out in this case. Then this means in our implementation, for example, we could expand in this way. So we know we want our backend to work with integers. So all of our entities will be in integers. But our controller now needs in its interface to support both flows, so integers and floats. So we don't want to break the front end, and we support this with a conversion to integers if we receive the amount in floats. Then the front end finally can migrate to the new interface, which is simply pass the amount in cents instead of the amount as float. And finally, when we have released the front end, we are allowed to remove the all deprecated flow from the backend. Okay, so as a summary, we'd like to use expand and contract when we are refactoring our application, and we should approach it from the inside out. Then next, I would like to talk about special considerations to have when the persistence is involved, so data and deltas. You might have noticed that I conveniently left out of the previous example the fact that we could have had floats also in the database layer, which would have been very inconvenient. But of course, we know that in real life, we're not always so lucky. So here I would like to expand a bit more on what would have happened if this was affecting also our database. So in our current state here, we can see, for example, if we had in the table the amount in decimal format instead of big int format, and let's say that our Anima repository would have been writing still in decimal format, what would be the target state between the two? We would like to have an evolution in our database that basically converts the column to the type big int and converts all of the historical data and results in a table that looks like this. And of course, in our target state, we would like our backend to write instead of the amount in floats, round it as cents so that it can be stored as cents. But how do we get here without breaking production? So one thing that lots of people I've seen doing when dealing with persistence is if the persistence is in the same repository as their backend code, sometimes they release both changes all at once because they are in the same repo. However, this, I would argue, can cause data loss because although things might be in the same repository, they are not necessarily deployed together or in a convenient order. Especially database evolutions are often applied before or after you redeploy, for example, your auto-scaling group. So we have the situation where all the instances might keep writing data in an incompatible format and cause some moments of data loss if we do this. So for example, if this is the table, we would have, with our migration, all of our existing values converted to integer. Then a moment of time where the application is still deploying and is still writing in the wrong format, which is floats. And so we lose basically all of the data that users are trying to write in that period of time. So this is not good. We should always isolate changes that are belonging to different components, even if they are in the same repository. It doesn't mean that they belong to the same executable or that they are deployed together. However, how can we do it? Can we apply expand and contract instead, as we have seen with the refactorings? So how could that look like? We could have an expand phase, in which we create simply another column, which is representing our second flow. It contains the amount in cents. We could copy all of the historical data while the old clients still write to the old column. In the migration phase, we could migrate all clients to write to the new column amount in cents. And in the contract phase, we could finally remove the old column amount. However, also this might cause some data loss. Why is that? Because we would do the expand phase here, and all of the historical values would be converted to integers. But then between the expand and the migration of the clients, we would not write anything in the new column amount in cents. So here we would lose these values over here. And then only after the migration of the clients, we would start to have users writing to the correct column. So is there a way in which we can apply this change but avoiding data loss? The answer is yes, with a database trigger. Suspenseful pause. Of course, database triggers can be a solution if we start synchronizing our new field with the old field as soon as it's born, the problem doesn't present itself. But however, if you're like me and the database triggers are not so attractive to you in, I would say, 2021, then maybe we can explore other options for this. What I propose is we could do something similar with a technique that I call preemptive double write, in which before the expand and contract, we want to publish a version of the application which writes to both flows but tolerates failure in the old flow. So here is an example. Before any expand and contract takes place, we could change the backend to write both into the amount in float column and the amount in cents column, even though this operation will fail because the other column will not exist at all. And here we have to, of course, tolerate the failure. We don't want to return an exception to our users. What does this allow us? To basically publish afterwards an evolution of the database in which we create the old column, and immediately the code that is in the backend will suddenly start working and writing to the new column as well, which means we don't have any data loss and they are properly synchronized from the start. Then finally, we can start our migrate phase of our expand and contract, and the client of our persistence can then swap to the new flow, which is only write to the column in cents. And finally, then we can contract our persistence layer by dropping the old column. Now, as you remember from the previous example, we are in the same situation as before. Why? Because we have our persistence now working in integers, our backend in floats, and our frontend in floats, which is what we saw before. With this, then we can apply the same procedure of expanding and contracting with the backend and the frontend, and finally reach our desired state, which is no floats anywhere. However, this was just for the persistence for releases, and to migrate the backend and frontend is gonna be 3 more. So this means 7 releases in total, as opposed to what would have been 3 if we could have had no continuous deployment and maybe some downtime. So this is an example of what could be the overhead in a system that has continuous deployment and is distributed. Although I would argue, I think it is worth it, but it's still something to consider. So the summary of this section is, please beware when you're working with data, because you might experience some data loss. And remember to, if you don't want that data loss, always use some kind of technique to prevent your users from receiving an error, especially if your transactions are very, very critical. Then final section I want to talk to you about is how do we plan for normal user stories having all of this knowledge. So we saw so far how to approach new features and how to approach refactoring. We would like to approach different changes differently depending on their nature. So with new features, as we said, we would like to use feature toggles and go outside in. With refactoring, we would like to use expand and contract pattern and proceed inside out. But the world is rarely that simple, is what I always find. And sometimes a user story or any given task might have actually a bit of both. So which approach do we choose when it is not so clear whether it is a refactoring, it is a new feature, it is both, we don't know. I would like to propose this example, which is a feature addition that would require heavy refactoring in our system. And it would be, for example, as an animal shelter volunteer, if we wanted to add different types of expenses that are not food expenses, this would require quite a lot of changes. You can see here in our interface, this is the feature we saw before. It would mean for us adding as well a type here in addition to the amount. So we are changing significantly the shape of the contract between the components because they have to pass an additional field, and we're adding a feature as well. So do we approach this outside in, inside out? We don't necessarily have to choose because there is a pattern that is preparatory refactoring, which we can use to solve this issue. And it is a pattern which allows us to modify a system in such a way before we have to add a new feature that the addition of the feature itself then becomes a trivial matter. So we would basically try to group all of the refactoring tasks first that allow us to expand our abstraction in a way that they can accommodate our features super easily. And then we can leave the feature addition to last. It means that the plan for our story becomes first do a refactoring inside out, and then add the feature outside in. And this could be an example of the phases. So our preparatory refactoring could be, for example, to introduce the type field to an expense. And this would be performed outside in. And of course, it would have a default of whatever expenses mean right now. So for example, it could be food only. And then the only functionality that we could add under feature toggle working outside in is to allow the user to actually pass to the API different types of expenses. So not only food, but also medicine and stationery. So here, the summary is when we are in doubt, it's better to make a detailed story plan to list all of our releases and really understand in which phase are we of a user story. Are we pre-refactoring the system to accommodate a feature, then we need to go in one direction, or are we in the feature addition part of the user story, in which case we need to go in the other direction. And ideally, it is really convenient to pre-refactor the system. So this is it. I would like to show the conclusions. So these are the principles we've seen so far of incrementally releasing software under continuous deployment in distributed system. We want to use feature toggles for adding new behavior. Then we would like to have expand and contract for refactoring. In one case, we go again outside in, and in the other case, we go inside out. We have to pay special attention to data to prevent episodes of data loss, if that is something that we want to prevent indeed. And always, let's plan our releases. So if there is one takeaway that I would like you to have from this talk is when we have continuous deployment and a complex system, we can't just walk into any user story and implement the changes as we see them in the target state in our head. We actually have to have intermediate states of the code base very, very often in order to guarantee that the users never see broken functionality. And this is something that you have to always take into account, and you can't just start developing just because you can imagine already what the code base is going to look like when you're finished. So that's the gist of the talk, basically. Just take into account the several steps and the continuity of the functionality in production. And that's it. Thank you very much. These are some resources that you can also check later when the slides are shared. And I think that's all.
Cool. Thanks very much, Valentina, for the talk. It was really interesting. And I think, yeah, it makes something that for many people is kind of an unknown secret or something that they don't really know how to approach really clear. So thanks very much for doing that. So I've got a question in the questions and answers. I think we have a few minutes to ask a couple, and if people want to ask you more, they can go to Slack, I guess. The question from Andy Muir is, do you regard toggling a feature toggle as a release?
So maybe we should clarify a bit the terminology here. Toggling a feature toggle for me is a release, but is not a deployment. So what I mean is we should try to decouple as much as possible our feature toggle state from our deployments. So I shouldn't have to release a new change in the pipeline, so on Git, in order to put a feature live. That is something that ideally could live somewhere else. It should be ideally even accessible by our non-technical stakeholders. So for example, do they think that this functionality is breaking everything, they want to turn it off, they could potentially have access to it. And to me, that is more aligned with the release terminology, because it is releasing a feature. And yeah. So
Well, that
I
makes
hope
sense,
that
yeah.
sort of answers the question.
No, I think it makes perfect sense that you're separating deployment from release, both in your terminology, but also you're advocating, I think, separating it in actual practice, that they should be able to be done independently. Cool. We've got another question, I think it's from the same person, unless we have a lot of Andy Muir's. How would you run integration tests as opposed to contract tests between a consumer and a producer? So I guess that Andy's getting at the state where you've got more than one thing that presumably changes on the service at least separately, but you want to check how they run together.
So in our case, our terminology is a little bit different. So we consider integration tests as like a test that goes, for example, against a repository class and really talks with the database, but not like as integration of multiple components. What we do have is end-to-end tests, which tests one component as a black box in isolation, mocking all the other components around it. And the way that those are mocked is by following those contracts. However, a more end-to-end sort of test even, which is maybe what I understand might be a bit closer to this terminology, is another thing we have, which is we have smoke tests. So for example, one way in which you could verify that the interaction of all of these systems goes well is to explain, okay, in our pipeline, we would deploy to a real environment the set of all the changes. And then that environment is a pre-production, and there are some automated tests that just verify more or less are the things that you want to see on the website actually on the website. Is there a giant 500 exception in the middle of the page? And those maybe, I guess, are more similar to what you're talking about. So yeah, this is how we do it currently.
Cool. Thanks very much. And I'm curious to know, like, you've talked about a lot of techniques and you've laid it out very clearly, but like, is it always worth it to do the careful staging and the story planning and everything, or when might not it be worth it to be that careful?
I guess it depends, which is the typical consultant answer. I would argue that it depends, especially on the requirements of your client or of your organization. For example, we talked about data loss, but realistically, unless you're working for a bank or unless you're working for someone with very high availability requirements, it's possibly okay that for 2 or 3 seconds, just time for your deployment to go through, some users get an exception, as long as it's not some ridiculous amount of time, and maybe it's not so crucial that every single action that a user takes is perfectly able to be saved and nothing is ever lost. So that is maybe one point where you could compromise a lot. At the same time, we've also talked about the requisite of no downtime at all and no feature degradation at all, which is also a point that you might be surprised how much your organization is willing to compromise on. You know, if you're having so much other complexity to your release process that it is significantly cheaper to just be like, you know what, I'll have an hour of downtime and save a month of development effort because I wanted to make these systems in a seamless way. But I think there is usually more room to talk about these things than we developers often think about. And it is worth to explore, you know, is it worth it all the time? Because yes, it is really cool, but it's a lot of overhead at the same time.
And so I happen to know, like, I think, you know, you've recently been working on e-commerce systems and so on, where, you know, any interruption is translatable into real money. So it's kind of maybe an inclination of the part of stakeholders then is to not let any of that, you know, those potential sales or that customer request drop. I know in systems I've worked on, we probably have used the YOLO strategy of just, okay, it's going to be a bit broken for a little bit, but like, as long as it's okay by the end of the deployment, then we're fine. I think we use that a bit more often. And I think we skipped earlier in my career, we skipped that step you talk about, which is crucial, which is aligning expectations with stakeholders, because I don't think we really gave them a choice. I think we kind of just said, oh yes, it's normal to get some 500s during a release. And like, maybe it's normal, but it's not inevitable. And if it's not important, who cares? If it is important, then like you showed us, there's plenty of ways to carefully avoid it if that's what your stakeholders need.
Yeah, I guess what's important, I think, is to be aware of both worlds, right? Of,
Yeah,
how would we approach the issue if we really, really cared about not having any downtime at all. And it's important that the team feels comfortable and mature in the practices in a way that they would be able to do it if they need to, but also it's perfectly fine to be able to negotiate it and really present this trade-off to stakeholders who might be interested in it. Yeah. And I've definitely
cool.
also worked, in kind of internal facing systems that definitely didn't have these requirements. So yeah, totally get your point, Chris, there. In that case, YOLO is, I think, is sometimes acceptable. And yeah, it shouldn't be stigmatized either.
Cool. And finally, where can people go to use this animal management system? I'm pretty sure a lot of people have seen it, and there'll be a lot of demand now that you've talked about it publicly.
I just got a picture from Google. What?
Fair enough. It worked out very well. Okay, thanks very much, Valentina. I think very useful talk. I think I can see people in the chat talking about how it helped clarify things for them. The next talk will be at 10 past. So as the same with every gap between talks, folks, you have 5 minutes to take a break or get some tea or something like that. And then we'll be back with the penultimate one of the normal talks.